All right, question 24 here on GRE Practice Test 1 in Section 5. I kind of like this problem. I think a lot of people, when you're like, do you like algebra more or geometry more? Like geometry, I'm very visual. I love the pictures. I hate algebra. That's such a bad word. After doing a geometry problem like 23, we see that sometimes geometry can be a lot more challenging than algebra. 24, if you solve this thing completely algebraically, it's pretty straightforward. What's going on here is we have this sequence of numbers. And what we're told is that each term after the first term, so here's the first term, some number, is equal to the preceding term plus the constant c. So if we just call A1, I don't know, A1, instead of calling A2, A2, we can call A2, A1 plus c. Because each term, A2 for example, is equal to the term before it, A1, plus some constant c. So then what about A3? Well, we could call that A2 plus c, but we shouldn't call that A2 plus c because A2 is just A1 plus c. So we could call that A1 plus c. In other words, A1 plus 2c. We can call A4 A1 plus 3 of these c's. We can call A5 A1 plus 4 of these c's. And now we have enough information to answer the question. We're told that A1 plus A3 plus A5 equals 27. So remember, A1 is just A1, but we're going to add to that A3, which is A1 plus 2C. And then we're going to add to that A5, which is A1 plus 4C. That sum is equal to 27. Can we simplify this a little bit? Absolutely we can. We got 3 of these A1 things, plus 2 of these C's plus 4 more of these C's. So we have 6 of these C's. 3 of the A1s plus 6 of the C's must be equal to 27. Uh-oh, there's a problem. I have 2 unknowns, A1 and C. I can't solve for A1, nor can I solve for C. That's okay, you don't need to. We're not asked for A1, nor are we asked for C. We're asked for A2 plus A4. And using our little cheat sheet over here, we know that A2 is A1 plus C, and A4 is A1 plus 3C. So over here we have 2 of these A1s, and we have 4 of these C's. We know that 3 of these A1s and 6 of these C's is 27. Can we figure out what 2 of these A1s plus 4 of these C's are? Absolutely we can. If you just recognize you could factor out a 3 from this expression, where, I don't know, down here maybe. 3 times A1 plus 2C is equal to 27. Right, pull a 3 out of here and a 3 out of here. Therefore, A1 plus 2C must be equal to 9. Right, but I'm not asked about A1 plus 2C. I'm asked about 2A1 plus 4C. I know. But if you'll allow me a long circuitous arrow, just like I factored a 3 out of the expression on the left side of this equation, I can factor a 2 out of this expression to get that this is just 2 times A1 plus 2C. Right, pull a 2 out of here and a 2 out of here. Wait a minute, 2 times A1 plus 2C, that looks really familiar. A1 plus 2C, didn't I already figure out what that is equal to? Sure did, right here. A1 plus 2C is equal to 9, so this is just 2 times 9, which is equal to 18. I think that's kind of slick. I love the algebra, but to be fair, I teach math for a living. It's entirely possible that you don't. If you hate that, let me offer up another solution. The fact that they're asking you what A2 plus A4 is equal to, when all we know is that A1 plus A3 plus A5 equals 27, tells us that A2 plus A4 must always be equal to the same number anytime A1 plus A3 plus A5 equals 27. What I'm saying is we can choose A1 to be whatever the hell we want and C to be whatever the hell we want as long as A1 plus A3 plus A5 equals 27. If this is true with our choice of A1 and C, then the answer that we get for our choice of A1 and C for the sum of A2 and A4 must be the same as this 18. So how can we choose A1 and C to make our life as easy as possible? Well, C can be any constant we want. Why don't we make C be equal to 0? If C is equal to 0, that means each term in this sequence is equal to the preceding term plus 0. In other words, every term in the sequence is the exact same number. What number would that have to be for A1 plus A3 plus A5 to be equal to 27? That number would have to be equal to 9, right? Because 9 plus 9 plus 9 equals 27. If C equals 0, A1 equals A2 equals A3 equals A4 and so on. And if these are all the exact same, the fact that 3 of them sum to 27 means that each of them individually must be equal to 9. If each one individually is equal to 9, then A2 is equal to 9 and A4 is equal to 9. So A2 plus A4 is equal to 9 plus 9, aka 18. A cool little trick when they're asking you questions like this of what number some expression must be equal to is recognizing that that number has to always be the right answer. So if they don't define some of the variables in the problem, you can choose them to be whatever the hell you want as long as it satisfies the information given in the problem. You don't have to make c equal to 0, right? You can make c equal to 1 and this will still work. It just makes your life a little bit harder because if c is equal to 1, then each number in the sequence is 1 bigger than the one preceding it. So now I got to work really hard to figure out what would A1 have to be so that when I add a number that's 2 bigger than it and then add another number that's 2 bigger than that, I get 27. I think if c equals 1, A1 will end up being equal to 7, right? Because 7 plus 9 plus 11 is equal to 27. And if that's the case, then A2 is equal to 8 and A4 is equal to 10. And I still get that 8 plus 10 is equal to 18. I'm trying to demonstrate that I'm going to get the same answer 18 no matter what I choose, but don't choose c equals 1 because that makes your life harder. It makes it harder to figure out A1. Let c be equal to 0. Make the choices as friendly as possible if you are allowed to make the choices, which you are if they're asking you for the value of an expression like this. I'm sure the test writers had this algebraic method in mind, but this method down here in brown can be a cool little shortcut for you.